thank you very much for joining us on the second day of the Future Print Tech Fest. And I am very pleased to have with me my keynote address for the day, for the first session. And it's Nick Copeland, our R&D Director of Bobst. Nick, hi, good morning to you.
A pleasure. Good morning, Fraser. And yeah, real pleasure to be here today for your Tech Fest.
Thank you very much. And listen, Nick, you've had something like 25 years of experience in the flexible packaging industry. So it's quite a broad range of knowledge you have. And I know that you're particularly interested in, I think, vacuum technology and barrier technology. And you're going to talk a little bit about that. You're also going to give us a flavor of kind of the mega trends of sustainability as Bobst has such strong relationships with those big brands that you get a real understanding of what they're looking towards in terms of material to use for packaging. Is that right?
It is, yeah, definitely. I think my focus over the last 25 years absolutely has been in the area of packaging, specializing on vacuum technology. And I think what really helps at the moment, based on this topic, really interesting topic of sustainability, Fraser, you know, people are trying to use the same materials. And the good thing with vacuum deposition, which is my area, and barrier technology, they lend themselves hand in hand. So yeah, it's a real interesting opportunity at the moment, very dynamic, with a lot of promises about sustainability from retailers and brand owners.
Sure.
So yeah, absolutely.
And I think we felt that this was a really good way of kicking off the Tech Fest, because it brings in both your kind of technical knowledge of materials and you know, as we said, also the side of the brands in terms of what they're seeking to use in terms of material to wrap products in, and also that impacts on what the print technology and the inks and so forth. So we'll talk a little bit about that at the end as well. So listen, I'm going to let you crack on and do your short presentation, and then we'll have a chance at the end maybe to have a few questions. So Nick, over to you.
Appreciate it. Thank you. So I'm just going to share my screen. Great. Is that okay, Fraser?
Yeah. Thanks, Nick.
Fantastic.
That's perfect.
Yeah. So again, thanks for the kind introduction, Fraser, and good morning, everybody. And honestly, from my side, it's a real honor and pleasure to have the opportunity to present at this Future Print Tech Fest. And I hope everyone's enjoyed the first day of the event yesterday. The title of my presentation today is Global Mega Trends in Flexible Packaging Materials and the Advance Towards Sustainability. In terms of a presentation synopsis or outline, I'll start by providing an introduction to the global sustainability agenda that we're all going through and the changes that are happening in our flexible packaging industry as a direct result of the pledges of the big global brand owners and retailers. I'll then try to cover the global market trends for flexible packaging, and also take the opportunity to explain the packaging laminate structure changes we are experiencing as a direct result of the sustainability agenda and the circular economy. I'll then refine the talk to explain about the technology changes on packaging structure materials and also the functional barrier layers, where there's a real market driver and push to use thinner monomaterial layers in the packaging structure as a way to really maximize the weight of the monomaterial component to support recyclability. And finally, I'll take the opportunity to share a new high barrier packaging structure approach to really improve recyclability, support structure standardization, whilst also enabling improved packaging structure performance while supporting this circular economy. So just moving on, by far the most significant and current market and trend in our flexible packaging industry is the topic of sustainability and the real global push and ambition to develop and offer more sustainable packaging solutions and structures to support a more circular economy. So what has initiated this strange push on sustainability? Well, stakeholders throughout the value chain are setting really ambitious sustainability pledges and commitments, which have really started to impact the general packaging and also the flexible packaging industry. In summary, the pledges commitments are to work towards using 100% reusable, recyclable, or compostable packaging. And timelines vary, but most of the timelines given are for solutions to be ready by 2025 or earlier. What I've tried to do on this slide, I've tried to capture some of the most recent public sustainability announcements, covering pledges from various global stakeholders throughout the value chain, from a resin producer, where I've got Dow, to a high-level converter with Amcor, a large brand owner with Nestle, and finally a retailer with a statement from Marks and Spencer's. But as a consumer, honestly speaking, we're inundated with announcements via press releases and social media announcements from all companies throughout the value chain on a daily basis, promoting their initiatives, commitments on developing and commercializing sustainable packaging solutions to try and support a more circular economy. And as a global machine provider at Bobst for flexible packaging, this is having a significant impact on our business as the material behaviors and the materials from a processability and performance perspective are quite different. And we need to develop new solutions to support the sustainability pledges. So when looking at the global market trends and current developments of sustainability, you can generally group the trends into what we call at Bobst the three main pillars of sustainability. Mainly monomaterial polymer-based solutions, where the main market driver is to use more polyolefin PP or PE-based solutions, which are based on a single polymer family, which really helps to enable improved recyclability. Now, there's different definitions in the market and the industry on what defines monomaterial. But we've based our definition on the European CFLEX Consortium definition covered by the Design for a Circular Economy guidelines, which state the packaging structure needs to be compatible with current mechanical recycling processes, and it must contain at least 90% by weight of polypropylene or polyethylene. And other components such as coatings and inks and adhesives can each have a maximum weight percent of 5%. The second pillar of sustainability is what we call compostable, biodegradable, and bio-based solutions, where the real trend or ambition in the market is to find home compostable solutions to avoid the need for consumer collection and sorting, or marine degradable to prevent ocean plastic pollution. And finally, the third pillar is also based on monomaterial, but this time based on fiber or paper-based flexible structures, also to enable recyclability. Today, it looks like the largest market volume for flexible packaging is likely to be based on the monomaterial polymer-based recyclable structures. And currently, polyethylene it seems to be the preferred route as the collection, sorting, and recycling infrastructure is currently more developed in the market. Although the packaging substrates and the materials are changing to provide more circular or sustainable opportunities, the performance requirements, unfortunately, are still the same. And the market expectation is to provide the same like-for-like performance as the traditional non-recyclable, compostable, or biodegradable solutions. And this creates a real challenge for the packaging designers, as the inherent properties of the new generation materials are generally inferior to the materials that we're trying to replace or substitute. In general, the circular or sustainable materials are mechanically extensible, They're thermally more sensitive, and they also have inferior barrier properties. And this can impact the shelf life of the product the packaging structure is trying to protect. For higher barrier applications, the market requirement generally falls into what we call two main barrier levels. The first one is metallized polyester replacement, where the market requirement is to have an oxygen and water permeation rate of less than 1 cc per meter squared per day for oxygen and 1 gram per meter squared per day for water. The second mega target on barrier performance is aluminium foil replacement, where the requirement is more challenging, and it's to create an oxygen and water barrier of less than 0.1 and 0.1 respectively. Based on the complexity of developing these sustainable high barrier packaging solutions to meet these sustainability targets, a significant change we're experiencing in our industry is the acceptance of stakeholders across the value chain to work together in developing partnerships and collaborations. We go from the resin producers all the way through to the brand owners and even the retailers. Partnerships and collaborations are taking place. As a machinery manufacturer, this is not something previously observed in our industry, and it's created from the necessity of developing suitable solutions to meet the pledges within the ambitious, fast approaching timelines, where the only real way to reach the goal is to bring together the industry experts to collaborate. As a machinery manufacturer for flexible packaging, it's having a significant effect on the way we do our business and developments, and we're actively working across the entire value chain with collaborations and partnerships from resin manufacturers to film producers to converters and also other machine manufacturers and brand owners. So if we now look at the market or technology changes in terms of packaging structures and the associated substrate material choices, in terms of packaging structures, we're observing two significant megatrends in the market. The first megatrend is there's a real big push towards packaging simplification, layer reduction, and delayering of the laminate structures. The second trend is a global ambition to move from non-recyclable mixed polymer solutions to more recyclable mono-material solutions as a way to support circularity and recyclability. For packaging simplification and layer reduction, along with substrate downgauging, this by no means is a new market trend or industry change. It's something that's been around for at least the last 26 years I've been involved in the flexible packaging industry. But it is more relevant today based on the global push for incorporating more sustainable packaging materials and the requirement to use the same material or polymer family in each layer of the packaging structure. The general trend is to try and what we call integrate or combine functional properties of the packaging structure into less individual layers. So if we take the structure on the left-hand side of the slide, we have a conventional 3-layer triplex laminate. The upper web is based on a printed substrate or web, which in this case, we use a reverse printed concept. The middle web is a barrier web using an opaque, shiny, metallized barrier layer as a way to provide the barrier functionality. And the bottom layer is the lower sealant web, which has been designed to offer the correct seal performance or window needed for the packaging application. If we want to simplify the structure from the triplex 3-layer to a simplified 2-layer bilaminate or duplex structure, we have a few options on how to design the packaging structure to combine these functional properties. For the example shown on the upper right-hand side of the slide, as the barrier layer is aluminium is opaque, and therefore we can't reverse print behind an opaque layer. So for the example on the upper right-hand side, we have to put the opaque metallized layer on the sealant web, and therefore combining the functional properties of barrier and sealant on the same web. For the lower example on the lower right-hand side of the slide, for here we're considering a transparent barrier using aluminium oxide or silicon oxide within the structure. And because the alox or the SIOX layer is transparent, we have the option of integrating the transparent barrier layer onto the printed web, where we would then, on top of the alox or the SIOX, reverse print onto that barrier web, therefore combining the print and the barrier functionality on the single web. So if we now have a look at the market or technology changes in terms of material choices and also barrier layers. And for technology changes on the packaging materials, this is the second significant global trend, which is to move from non-recyclable mixed polymer packaging solutions and structures to more recyclable mono-material solutions. And to help illustrate this market change and impact, we've shown a typical packaging structure on the left of the slide, which is based upon a multi-material duplex laminate structure. It consists of a standard 12-micron polyester film with a thin alox barrier layer, and that also has a protective polymer layer on top of the alox, which is then reverse printed before being laminated to a 75-micron polyethylene sealant web. And to help illustrate the potential recyclability via the amount of mono material in the structure, again, we've used the CFlex guidelines as a basis to quantitatively compare solutions. If we use the percentage weight of the polyethylene in this first mixed polymer solution on the left, we can see we have a non-mono material weight percent of about 25.5%. This is obviously significantly more than the 10% CFlex guidelines, and hence the drive to move to more mono material structures. For the structure on the right-hand side of the slide, we have a two-layer bilaminate structure again, but this time it's made up of a 25-micron machine direction orientated polyethylene, and again, a 75-micron sealant web. This time for barrier, we've added a co-extruded EVOH layer to the skin of the MDOPE. And this is to provide some oxygen barrier coming from the EVOH chemistry itself, but also to provide a metal or metal oxide receptive layer to add on the metallizing step. With this particular structure, the layer thickness and also the polymer or resin densities can be changed or optimized as a way to change the weight percent of the PE monomaterial component. But in general, it's also quite challenging to meet the industry requirements or the industry targets. We're also observing in the market some further requests beyond the CFlex guidelines for higher monomaterial levels to help satisfy tightening circular economy targets, and such as Scandinavia. And for this solution, we need a new barrier solution or a new barrier structure to satisfy the requirements. For the final part of the presentation, I want to focus on a new packaging structure concept or approach to try and support a more circular economy. Again, it's complex. The requirements in the market to move to sustainable solutions are challenging. So based on this complexity and challenges around creating this suitable monomaterial, high barrier packaging structure to satisfy the market requirements, we believe there needs to be some level of packaging structure standardization as a way to really simplify the market solutions. And this new concept we're illustrating here tries to address this need by offering a standardized high barrier solution based on a pre-made monomaterial polyolefinic polypropylene or polyethylene laminate structure. That pre-made laminate can then be last minute tailored with the relevant surface print technology selected when needed for the application. So beyond just the standardization of the pre-made high barrier laminate concept, it also offers many benefits, and I'd like to try and focus on a few of these more important benefits. The first thing for me is barrier performance. The barrier package concept is based upon wet dispersion coating, not co-extrusion, and also dry vacuum coating to provide two very thin but complementary transparent high barrier layers. Removing the ink layer from the embedded structure also helps to maximize the barrier performance and reduce the barrier loss through the printing onto a brittle or non-protected inorganic ceramic barrier layer. The next is the laminate bond strength. And via removing the ink layer from the embedded structure, any limitations related to the laminate bond strength related to the ink are now removed. So we can obtain and achieve higher laminate bond strengths with the removal of the ink layer from the pre-made laminate. So in summary, the benefit of the pre-made laminate concept creates a standardized high barrier mono-material concept to allow for last-minute print tailorization, allowing for different printing technologies to be used on the same standard barrier structure. So this could be a long-run gravure job, it could be a medium-run flexo job, or it could be a very short-run tailored digital print job. So surface print on a pre-made high barrier laminate creates some challenges, but it also creates some opportunities when thinking about removing or separating the surface print from the layer in terms of recyclability. So that concludes my presentation, and Fraser, it would be a pleasure to take some comments from your side.
Thank you very much. If you just go back to the two of us, that'd be great. Stop sharing, that's fantastic. Thanks, Nick. That was very interesting. And who would believe that packaging is so complex in terms of the material? Unbelievable. Particularly when you see so much of it kind of just discarded and thrown away. It's just amazing that how much work goes into it. I guess because we're Future Print Tech Fest, I wanted to ask you, from the point of view of the challenges from a print perspective, what do you think in terms of these new substrates and substances? What are going to be the massive challenges for the print industry?
Yeah, I think, coming back to the brand owners' expectation and requirements, they want a sustainable circular solution with these new generation substrates. They want cost parity, they want performance parity, and they want processability parity. It's challenging. From a print perspective, I think the challenge is, if we analyze, again, I covered it in the slides, but if we analyze the materials, typically these materials they're more extensible, they stretch more. So when we throw energy at these materials, when we talk about creating registration on printing, when we talk about thermal damage, whether it's coating, lamination, or vacuum metallizing, we've got to think about the extensibility. And from a printing perspective, how do we deal with that extensibility in the materials? The next thing is the heat sensitivity. So they're mechanically less stiff, but they're also heat sensitive. And again, that creates some challenges from a printing perspective where we're adding materials that we want to dry. The third aspect, Fraser, I'd probably say is the chemistry.
Yeah.
These materials are typically non-polar, and what it means is they don't accept the print technology like the traditional polar receptive materials. So coming back to print reception, wet out, good print quality on these more challenging substrates, I think that's some of the challenges we're all going to cover with printing, but also in general through the different conversion processes.
Yeah, sure. And how are manufacturers of inks, manufacturers of technology, how are they going to work with you and with other organizations to work out the materials? What's the next step?
Yeah, I think, again, coming back to the whole value chain, we all have a role. The ink producers have a role. But again, looking at the challenges from a substrate perspective, the film producers are also trying to address some of the challenges in terms of extensibility, in terms of thermal resistance. What we're also trying to do is help to provide improved surfaces for printing with the aid of thin metal receptive or print receptive layers. So things like where before we were printing directly onto polyester, perhaps we need thinner, more print resistant or receptive polymer layers as a way to provide that improved print performance. But also for me as a barrier guy, Fraser, I'm a barrier guy. Same question. I need better chemistry to accept not just the ink, but I need better chemistry to accept the barrier layers.
So are you working with other organizations in collaboration to try and kind of move forward on this?
Absolutely. You know, we mentioned about the collaboration, even from machine manufacturers to the whole value chain, but coming to the raw material providers, yeah, we have active collaborations with all the main players of raw materials from inks, adhesives, and coatings to help to try and find solutions on these more challenging substrates. Remember the timeline, 2025 is around the corner. So we have to work together. And yeah, we've got many collaborations with those partners as well.
Yeah, and you talk about the substrate and the material changes in FlexPack based on these kind of, the impact of sustainability. What's the main material then that's being considered in the market at the moment?
I would say, yeah, when we look at the three pillars, for us, probably the biggest market opportunity would fall under what we refer to the monomaterial polymer based. And today, because of the maturity of the recycling infrastructure, the collection, sorting and recycling infrastructure for PE, our money in terms of, we call it the horse race, today would be the polyethylene route. Right. So monomaterial based on PE. Unfortunately, that does create some challenges in terms of performance and processability. But because of the maturity, it's not just about creating a solution that's designed to be recycled ready. It's actually about using the infrastructure that exists today to create real recyclable opportunities. Yeah. And that really comes under the PE stream.
And I guess this means that there, it's for some converters, for packaging companies, there's going to have to be some work to be done, isn't there? This is a change.
Definitely. Honestly, these materials handle differently. And I've mentioned about printing, I've mentioned about lamination and vacuum coating, but also on the packing lines, the processability of these packing lines, the sealant of the structures changes. The question is, can these existing lines be retrofitted to be upgraded to handle, or is it new assets?
Yeah, that's kind of what I was wondering, Nick. So from the point of view of Bobst and as an organization, how are you tackling this and supporting your customers in this kind of process?
Yeah, I think because the ambition on performance is not changing, we're still trying to find solutions that give the same performance. At Bobst, because we've got the different divisions within the group where we supply equipment both for vacuum metallization, for the various printing technologies that we've got from gravure, flex or digital, then through to wet coating and lamination, I think it really helps the synergy between the different elements, because again, it's not one solution that needs to be developed and resolved.
Yeah.
And I think what I'm finding more within the 26 years that I've been working with Bobst is now we've got a real opportunity to collaborate internally with the different product lines and trying to develop solutions, what we call end-to-end solutions on the different platforms.
Sure.
The machines are becoming more connected.
Yep.
We're moving to digitalization, and
Yep.
we're creating sustainable solutions and sustainable connected solutions.
Yep.
And I think it really helps Bob's strategy and vision and meets the requirements of the brand owner targets on sustainability.
Yeah, yeah, and I think that's one of the things we've sensed from talking to Francois Martin and from CEO of Bobst, is that there is generally, a passion in the organisation to help take customers with you on the sustainability journey that's driven a lot by brands, but also by a desire to improve where we go with this. So yeah, I'm grateful for the insight that you've given us today. In terms of conversation, we're kind of coming to the end, wrap up. Was there any final comment you'd like to make? I was just going to say that obviously, if people want to get in contact with you, we'll put the email address up so that people can have a chat with you if they want to. Is there anything else you wanted to add, Nick, just as a final comment?
Yeah, I think, again, coming back to one of the slides about collaboration, there's very, very challenging timelines, and we all need to work together to create these solutions. I would say as a machine manufacturer, it's fairly new concept over the last 3 or 4 years where we're working through the whole value chain, but honestly, it's not something that we can develop alone. So we have to work with our customers' customers, and our customers' suppliers through the value chain to achieve the goals and the ambitions. So for me, I'd really look forward to working in collaboration. And to close, I'd just like to say we've got the motto of shaping the future of the packaging world, and it's true. And we have to do this in collaboration and partnership with the whole value chain.
Yeah, yeah. Thank you. I mean, to be honest with you, it's interesting. Throughout our Tech Fest, that word collaboration has come up so often. It seems to be the watchword for going forward, really, doesn't it? Being one company trying to deliver all solutions is such a challenge in the current complex world that we live in. So I think you've summed it up very nicely. Nick, thank you very much for joining me on my keynote address for the morning, and hope to catch up with you soon.
A real pleasure. Thank you very much, and thanks for the invite.